Everyone, in this video we're going to now look at the financial applications of both arithmetic and geometric sequences. So just a quick summary of the financial applications, first of all, of arithmetic sequences. So simple interest goes with arithmetic sequences, and you should know that compound interest is an example of a geometric sequence. So when we're looking at investments and loans, basically it's the same thing, but I shouldn't say it's the same thing, because it isn't the same thing. I mean, you'd much rather an investment than a loan because it means you've got money, but the way we calculate it is pretty much the same in terms of both of them are examples of growth, but we'll get back to that later. So simple interest, investments and loans. So remember, simple interest goes up by the same amount each year or each compounding not compounding period, each period, because it's not compounding, it's just each period. Whereas compound interest, investments and loans, remember, the amount changes because you're effectively getting interest on interest. Here you can see the recurrence, relation and rule. Going back onto the simple interest, just because it's not a huge part of the general maths course. I mean, we do still have simple interest on the study design, but I find it usually combined with geometric. So we'll do a video of that later. But if you're thinking, why isn't there any recurrence, relation or rule? Well, we've got them there anyway. It's an example of linear growth, so they're on the previous page. All right, so let's get stuck into some questions. So I'm only going to do one example of each. Oh, actually we'll do loans and investments and then we'll do depreciation. I should have probably talked about them first. All right, so let's have a look at loans and investments. So just to recap, a loan is when you, and I'm going to talk about banks. It's just much more easier than talking about financial institutions. Okay, so when I say bank, it's any financial institution. So if you've got a loan, that means you are borrowing money from the bank. If you're investing, you're putting in your own money into the bank. All right, both of them accrue interest. Obviously, if you've got a loan and you're accruing interest, you're actually going to have to repay that as well. That's why it's always not a real good idea to always get a loan. The biggest loan most people will have is their home loan. People might have a car loan, but you can take out a loan for anything. You can get a personal loan. But, I'm not going here to give you financial advice, but you probably don't want to be doing that, all right? Because you end up paying more than whatever it is worth. So if you took out $2,000 to buy a MacBook, you could end up paying $3,500 for that MacBook. All right, so, and you can only sell it probably for $1,000. Anyway, again, not here to give you financial advice. As for investments, so the interest on that is your money. So let's say you inherited $10,000 and you don't know what to do with it. Maybe you're too young to do anything with it. So you put it in the bank and over time it accrues interest. So, let's say when you're 30 and you're ready to take that money out, it's no longer just $10,000, it's gone up in value. So it might go up to maybe $15,000. So you've earned $5,000 in interest, which is pretty awesome. Okay, let's get stuck into some questions. So the following recurrence relation can be used to model a simple interest investment of $2,000, paying interest at a rate of 3.8% per annum. All right, so here we've got a recurrence relation. You should be familiar with recurrence relations by now. So our starting value, remember, is always V0, or it could be a different letter, but in this case it's V. So we're starting off with $2,000. It also tells us that in the question, which is very, very nice. And we've got an paying interest at the rate of 3.8 per annum. Now, you're probably thinking, where is this 76 come from? Now, that is our common difference. And without calculating it, I can tell you that is probably 3.8% of 2,000. So if you didn't have this $76 given to you, let's just do that. So 3.8% of $2,000. All right, so let's just change that into a decimal. So that's how we would put it into our calculator. I know I've got my calculator here. All right, let's go back to the main screen. So 3.8 divided by 100 times 2,000. All right, and there's the 76. So if the common difference wasn't given to you, you would have to calculate that, but that's just 3.8% of 2,000. All right, use the recurrence relation to show that the value of the investment after 3 years is $2,228. Now, it's very important that we're doing this question. One, because they always appear on exams, and two, you need to know how to show that questions. Now, this isn't just a matter of writing V3 equals and maybe using the rule or just even writing that. A show that question for recurrence relations is showing each iteration. So what I mean by that is you're given V0, so you don't really have to write that again, although I'm going to. You have to show V0, V1, V2, and V3. All right, you have to show all of them. So to show that question, if you did not do each iteration, it would be marked incorrect. So just remember, show that questions. You should be, when it comes to exam time, doing heaps of practice exams, and you'll see these pop up. All right, you've got to show each iteration. What I mean by iteration is 0, V0, V1, V2, V3. All right, that's each iteration. All right, so much talking. All right, so V0 that's getting given to us is 2,000. V1, we take the previous value, which was 2,000, and we add 76. All right. V2, we take the previous value and add 76. Let's see if I can do that in my head. All right, and then for V3, we take the previous value and we add 76. All right, so that's what it means by show that. You could have a a recurrence relation with the geometric sequence or a combination of both. Just make sure, and this one, we don't have to do any rounding, but you always round to 2 decimal places, because with financial maths, we're not a fancy cafe. We've got to show 2 decimal places and make sure your rounding is correct. If you struggle with your rounding, that's something you need to work on, because you would hate to do so much work on a question and get it wrong because you couldn't round it correctly. All right, let's move on to B. So use your calculator to determine how many years it takes for the value of an investment to first be worth $3,000. All right, so I'm going to show you a couple of ways. I'll just move this calculator up a little bit so we can see the buttons. All right, so we're starting off with $2,000 and we add 76. All right, so that's V1, which we've already done. Then we're going to add 76 again. That's V2, which we've got. Now I'm going to keep counting until I get more than 3,000. All right, so we're at 2. So notice I've done this twice. Now I can just keep pressing enter. So then we've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so 14 years. Now, I think that's quite a tedious one to do. If it was like only a few years, that would be fine. But getting that high, you might miscount, or you might second guess yourself, and then you're wasting time doing it again. So another way you can do it, going into your menu, go to sequence, and you can just write your recurrence relation here. All right, so AN plus 76, and our starting value is 2,000. Tick that off. Come on, let me tick. Okay, and then we can just look at our table. Oh, did I untick it? There we go. All right, and then you can just scroll down and get to your 14 that way. I would probably prefer this and keep pressing enter because, you know, it's there for you. As long as you've put your recurrence relation in correctly, then that should be fine. Another thing you could do is create a rule and press solve and do solve, which is probably not the most common method, but some students prefer that. So what I mean by that is the rule for this is Vn equals 2000 plus 76n. We want to solve for n, and we know we want it to be more than 3000. All right, you can solve that by hand, or you can just do it in your calculator if you prefer. I kind of think if you were going to the effort of doing this, you're probably more confident just to go straight to solve. And I did my inequality sign around the wrong way, I just realized, so let's get rid of that. Where is my calculator? All right, so 2000 plus 76, and I'm just going to use X because I'm too lazy to go into the other menu. All right, so here we've got X has to be greater than 13. So I can't round down to 13 because I won't have gone more than $3,000. So obviously N has to equal 14. All right, so that's another way you could have done it. All right. I might just, let's just do this one anyway. All right, so we've got a recurrence relation for an investment. All right, so I might go through this one just because it's a good one to actually think about what is happening in your recurrence relation, although I might just talk about it as opposed to writing everything down. What is the principal of this investment? That's your starting value. So usually in an exam, you start off with a very easy question. So that sort of question is like a gimme mark. So aiming to get close to 100% of people getting it right. So what's the principal? Easy peasy. There it is. How much interest is earned each year? Another easy one, $525. It's just interpreting what is happening with your recurrence relation. Part 3, calculate 525 as a percentage of 15,000 to find the annual interest rate of this investment. So if we're calculating a percentage of something, we take the value, so 525, divide it by what it is out of, and multiply by 100 to turn it into a percentage. All right, so we can just go shift, divide to get our little thing up, 525 over 15,000. Oh, come on. Sometimes it just doesn't like to cooperate, but it's been quite good lately. Times 100. Yeah, there we go. You want to sleep. It's falling asleep on me. All right, and it's 3.5%. All right, state how many years it takes for the value of the investment to first exceed $30,000. So remember, there were 3 ways you could have done it. Remember, it's same as question B. So you could keep pressing enter, you could use the sequence function on your calculator, or you could set up the rule. I'm probably pushing more for the sequence function because I think it just really shows you what's happening, and they're giving us the recurrence relation, so it's nice, should be nice and straightforward. All right, so we're just putting that into our calculator. Now just make sure you put it in correctly, because if you miss something or you write the wrong number, then the whole thing's going to be wrong, unfortunately. All right, so we just got to scroll. All right, and it has to be first exceeding, so over 30,000, so 29 years. Now, before I write that down, just remember, if you can't see all these values of n, the button you need to pick, I don't know where you can see it, is this one up the top, where it says X, Y with the arrows. You want to start at 0. You don't have to, but it's probably just easier to have it set at this and go as high as 50. If you get a question that's higher than 50, I think it's highly unlikely. You can always just, you can leave it at 100, doesn't really matter. I don't think it's going to slow down your calculator too much. Oh, there's the answer. So 29 years, I'm going to bother writing it down. All right. Now, Let's go to geometric. Okay. So here we've got geometric common ratio. We're only looking at the basics. So in another video, we're going to look at ones where you've got repayments and different compounding periods. This is just your basic stuff. All right. So your value of R is equal to 1 plus R over 100. But in another video, I will talk about when you've got different compounding periods, and we'll look at the application of financial with harder questions. These are pretty easy because you're not combining both geometric and arithmetic. Anyway, let's move on. The following recurrence relations is to model investment. All right, so we've got our initial value of $5,000, which is what question A is asking. The annual interest rate that it is applied. Now that is not this value here. That is your common ratio. And remember, your common ratio is calculated there, which I circled before. So I'm just going to write that down. So we are solving for little r. So this part here is your common ratio, so 1.05. And some people will be able to just solve that without having to do any calculations. But I'm just going to show you how to do it in case you're not confident to do it in your head. All right, so we can always just go to solve. So 1.05 is equal to 1 plus. And you can do R, but you know, it's going to take a while to find it. So I'll just use X. Just make sure when you copy it down, your answer down, you don't do X. So what I mean by that, don't write X equals 5, because it's not X, it's R. R equals 5. So 5%, let's just get rid of that X at the bottom. All right, so an error sometimes students make is when they transcribe things from the calculator, they write the wrong letter. We don't want that to happen. State the value of the investment after 1 year. So on the calculator, oops, that wasn't the calculator. This is the calculator. We are just basically doing 5,000 times 1.05. All right, so 5,250. I'm just seeing if this is any different. No, so pretty much the same thing here. Putting it into the sequence, and you can just find, so I would do it for both A and B, because you're finding the value for 1, 2, and 3, and then looking at when it exceeds 265,000. So putting your recurrence relation into the sequence function into your calculator, and then it'll easily answer A and B for you. All right, I just want to do a harder question. All right, let's have a look at this one. Oh, actually, I think, let's do a loan. All right, so the loan and investment are the same thing. You can see I've just changed to say loan, but it's not a mistake on the thing. It's just because this relates to loans, not investment, so it's the same thing for both. All right, I just want to do a harder question, so I'm going to scroll. All right, let's do this one here. Don't know whether it's the hardest, but I assume the later one is going to be the harder one. The value of a loan is charged compound interest every year, is modelled using the recurrence relation. How much money is borrowed? Easy peasy, there it is, $2,000. What is the annual rate for this loan? Now we did this before in the previous question. Remember, we did solve. So if I just go to my calculator, I can go back up. No, did I do solve? Yeah. So 1.06, just change it there. Most of you will probably know what the answer is going to be, but let me just copy that down. It's being temperamental. All right, change that to 6. And there we go, 6%. Write down the rule for the value of the loan after n years. So we haven't looked at changing a recurrence relation into a rule in this video. So let's, oh, don't want that, I want the pen. Can we be able to read that? All right, so we're doing question B. So our rule, remember you got to get used to using your bound notes. Okay, so have either your own or these notes with you. You should be doing questions with your notes, not doing questions and then at the end writing your notes. It's a good idea to use the notes as you're doing questions so that you get used to what is in your bound book and you're more familiar with it. You're like, oh yeah, I know what's on that page. And if you're a visual person, even better, because you'll probably end up starting to remember, oh, that's the page where the pig is or something like that. All right, so here's our rule. So our value of R was given to us, remember it was 1.06. So it's just going to be, in place of this, we've got 1.06. All right, we don't need to even calculate R. It hasn't given us an interest rate. It's already, what we worked out the interest rate was 6. So 1.06 to the power of n times V0, which was 2000. Let me just go back. All right, so Vn, all right, just make sure you get the letter right, is 1.06. So the value of R, which was given to us in the question, to the power of n times V0, which was 2000. So that's your rule. Question C, use the rule to find the value of the loan after 4 years. So all this means is wherever we see n, we put the number 4. All right, and then we're not using recurrence relations. We can just put this straight into our calculator. So 1.06 to the power of 4 times 2000. All right, and we're going to have to round to the nearest cent. Now, if you're not confident with rounding, I strongly encourage you to write more decimal places and then do your rounding. So 2524.9539. And then do your rounding. So when we're rounding to 2 decimal places, we do a cut there. So it's just going to say it's 95 cents. You don't really need to put the dollar sign in, but it looks kind of weird without it, so we'll put that there. If the loan is fully repaid after 6 years, what is the total interest that is paid? All right, so a little bit different to what we've done before. So after 6 years, so we're doing V6 this time. So we already had the rule. Now on our calculator, I can just drag, oops, I've got a 0 there, just drag that down. Instead of to the power of 4, it's going to be to the power of 6. So 2837. Now on an exam, I probably wouldn't bother writing this down, 0.4, unless it was worth more than 1 mark. I would just do it all on the calculator. All right, so I'm taking V6 and subtracting the $2,000. All right, and I can see that's going to be $837.04. All right, so that's how much interest we paid on the loan to the nearest cent. Oops, I just see blue and I go to the wrong thing. So on an exam, you could just write that. I'll drag it down, subtract 2,000, and there's your answer. All right, just make sure you do your rounding correctly. All right, now let's have a look at depreciation. Actually, I might pause, stop the video here and do depreciation in a different video. All right, bye.